Alright, so here's our problem, and it says to use exercise 28, and so I've written it down here. I know what you might be thinking. You might be thinking, oh, hey, look, Folland made a typo. He forgot to end his sentence in a period. Well, that's not the end of the sentence. The sentence continues, it's by blah, 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 and he tells you how to do the problem. But anyways, we're going to solve this problem. So first, recall that P is equal to 1/2 TF plus F, and N is equal to 1/2 of TF minus F. So now, by exercise 28, this, and so here, how do I want, by exercise 28, for all x in R, we have the following: Tf of x plus f of x. Well, this by definition is just mu Tf negative infinity to x plus mu f negative infinity to x. And now using here's where we use exercise 28. We have mu f of negative infinity to x plus mu f negative infinity to x. And then what is this? This is just equal to 2 times mu f plus minus infinity to x. Right? Why is this? Here's a really good kind of neat explanation of why this is. So let's just look at look at these as functions. What does the function absolute value of x look like? That just looks like this. It's like a v. What does the function x look like? That's just a vertical line. Now, what if we were to add these together? What would we get? Well, we would get a new graph. And what would this look like for negative values? Well, here we have these things would be positive and these things would be negative, and they would all cancel out. And so for negative, these would be 0. But for positive, we get this, and these two slopes both contribute. And so what we're going to end up with is we're going to end up with a line that has twice the slope of what these two slopes had. And these two functions have slope 1 for positive x, and so this one's going to have slope 2 for positive x. And so by this same logic, when you add the total variation of mu f to mu f, you get 2 times the positive part of mu f. So, okay, there we go. Okay, so what does this mean? So mu p negative infinity to x, well, that's just what px is by definition. By the definition of mu p, this is equal to p of x. And by definition of px, this is 1/2 times tfx plus fx. But we just saw up here that tf plus f is equal to 2 mu f plus. And so because we're taking 1/2 of it, we're going to get 1/2 of 2, which is, hold on, give me a second. That's 1. So we've got mu f plus, and then we've got negative infinity to x here. This holds for all x in R. So I'm going to write it like this. mu p e is equal to mu f plus e for all e in this collection, the collection of open rays, or closed rays, negative infinity to 0, where x is in R. And we will define this to be equal to E. But the sigma algebra generated by this collection is equal to the Borel sigma algebra on R. That's a very simple exercise if you haven't seen it, or if you don't know it off the top of your head. Just go back and review it. But you can construct all open sets and closed sets, and you can construct the Borel sigma algebra from these things. And so here, because this is true, we have mu p is equal to mu f plus on Borel R. And that just means that mu of f is equal to, or mu of p is equal to mu of f plus. And that is the desired result. And now I'm going to pause this and make sure that everything got captured, and then I'm just going to, for the other inequality, I'm just going to erase some stuff and it'll work. Alright, we are all good, so I'm going to go ahead and show you how to do this for the minus case. The reason I want to do this is because we're just going to replace a bunch of these pluses with minuses, because that's basically all you need to do. This plus becomes a minus, plus becomes a minus, plus becomes a minus. And let's see here, if we're doing the same argument we had before, then what we get is this. And so this time it's going to be 2 of f minus, because f minus is the negative part. So anyway, mu of Pn is equal to n of x, and this is 1/2 this minus this. That's equal to mu f minus this. This holds for all r, so blah 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 equals blah 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 blah. For all e in here, script d, but this is this, and so mu of n is equal to mu f minus. And now we are done with the proof.